Bismillahirrahmanirrahim. Assalamu students, I'm Sabir Hasnain, your science subject teacher from grade 8. In this video lecture, we'll discuss about corrosion from chapter number 3, reaction of metals. Students, if we put iron rod or some metallic material outside our home, after few days we'll observe that there would be a layer at the top of that iron material. Look at the figure. Definitely initially this metallic surface was refined, but later on with the passage of time it's not in the pure form, it's not in the refined form. The reason is actually corrosion. So what is corrosion? Corrosion is a natural process that actually converts a refined metal into a more chemically stable form, such as its oxides, hydroxides or sulfides. Question is this: what is the reason behind that? The reason is very simple. As we know, metals have high or low reactivity series. Some metals are more reactive, some metals are less reactive, and they are reactive with water, they are reactive with acid, they are reactive with air as well. That's why they do chemical reaction with those metals, and metal reacts with water, air or acid, and that's why it's a gradual destruction of the material, usually metals. So by a chemically and or electrochemical reaction with their environment, and that's crude that specific metal. So metals which are actually high in reactive series, which are most reactive, cannot be used to make different things. If we take the example of car, we cannot make car with a high reactive metal because it will corrode quickly, it will react quickly with acid, with air, with oxygen as well. So corrosion is actually a problem for metals of low reactivity series as well, not only for the high reactivity series but for the low reactivity series as well. So definitely there would be some method through which we can protect or prevent corrosion, protect anything from corrosion, or prevent how we can prevent different things from corrosion. We can prevent metals from air, water, etc. to avoid corrosion. There are different methods. First one is oiling. We put oil on different materials. By oiling, we can reduce the corrosion, because when the layer of oil is at the top of metallic surface, so water and air will not be in contact directly with the metal, and there would be no chemical reaction which avoids corrosion. Similarly, if we use grease will do the same thing. When grease will be at the top of metallic surface, there will be no direct reaction with air and water. And if we do paint, if we take the example of cars, aeroplanes, or different metals at our homes, so by painting them we can avoid the corrosion to our cars or aeroplanes. By using oil, one more thing, this can reduce the friction as well. Fifth method, electroplating. Look at the figure. Chromium plating, we use chromium plating. Kitchen stove, taps, car grills, wheel rims, bicycle bell and bicycle handle. These are actually the main examples on which metal is on the surface of metal. We use chromium to prevent the corrosion, and this reduces the corrosion process, because at the surface water and acid or air will not react directly with the metal surface. Now, sacrificial protection. Sacrificial protection is actually used specially for ships. At the surface of the ship will mostly remain in water. So we have two different layers. The inner layer is a less reactive, and we put an outer layer which is high reactive with water. So for example, we use magnesium in this case. So when we use magnesium, for that purpose, water reacts directly with magnesium because that is the outer surface, and the inner surface, which is iron, will not be affected. And later on, we remove that magnesium from the surface, which keeps the inner material iron without corrosion. Now, beating corrosion using alloys. How we can reduce corrosion by using alloys? Now, this is very interesting. Most corrosion problems can also be solved by using metal alloys. As I told you, alloy is actually a mixture. So what is metal alloy? Metal alloy is a mixture of two or more metals. When we add one metal, iron or copper, with any other metal, that is actually called metal alloy. So metal alloys are made by melting two metals together. When we melt two metals together, then allow them, those metals, their molten form, to cool down and harden. That is actually the alloy of those metals. So corrosion problem can also be solved by using unreactive metals, but not for every time. If we take the example, when we use the unreactive metal, this is because most unreactive metals are expensive and quite often. For example, we know that there are three unreactive metals: silver, gold and platinum, and they are very much expensive. So it's very hard, it's very unfair to use these metals. So when we consider the example of platinum, it would not be suitable for building cars, aeroplanes, because it's soft and weak. Same like gold and silver, they are also weak and soft. That's why we avoid to use the unreactive metals mostly. Now, steel is actually a metallic alloy. Steel is commonly used as an alloy. There are a lot of different alloys of steel, but we are discussing one of them, in which iron is 85% and chromium is 15%. So the main metal in steel is actually the iron, because it's 85%. So alloying the iron with the nickel and chromium also produces steel. As I told you, there are different alloys of steel. One of them is in which iron, nickel and chromium are mixed, because it's strong and rust resistive as well. There are other alloys. For example, bronze. In bronze, 85% copper and 15% tin, which is stronger than copper, and it is used to make coins and statues. This is how we can prevent corrosion of metals through different ways.